Now, let's calculate the index of coincidence for English alphabets. We already have the frequencies of letters in English, and which is given in the earlier section. So, for example, the frequency percentage for letter A is 8.16 and B is 1.4, something like that, right? So, to calculate the IC, we just make it square, then the value is very close to the sum of this whole thing, and it turns out it's 0.065. So that's the IC for the English letters. But if you have a language with 26 letters, same number as the English, but each letter has same frequencies like 1/26, then the IC for the language will be 0.038. So all the letters in this language appears in the same probability. So if you have monoalphabetic cipher, then the frequency of the letters in that ciphertext must be same as these results. So the frequency of the regular plain text letters. So the IC for that monoalphabetic cipher should be very close to this one. Okay, so if you have a ciphered message and if it's long enough, and when you calculate the IC of that ciphered text, and if the result is very close to 0.065, then we can assume that is monoalphabetic cipher. But if it's way less than 0.065 and very close to 0.038, then we can assume that cipher is maybe the polyalphabetic. Okay, so let's look at the message that we had before in this section. So likely this one, and it has about 450 characters on it. So please count the frequencies on each letters on it, and this is the result. So letter A appears 80 times, B appears 31. So it's not equally likely, but let's calculate the IC of this ciphertext, and it turns out that it's 0.047, and this result is way closer to 0.038 than 0.065. So we can assume this cipher is polyalphabetic. So this is how we could figure out whether the given ciphertext is monoalphabetic or cipheralphabetic, so the polyalphabetic. And so you need to calculate this IC to figure out that.